Hello everyone, and welcome to a Poplar Creek Public Library production. My name is Isabel and I'm from Teen Services, and I'd like to thank you for joining me today in my online program, Fingerprint Forensics, where we will be learning how to lift latent fingerprints. In this video, I'll be explaining the basics of fingerprint patterns, the differences between visible and latent prints, and how to lift them by using dusting and fuming techniques. If you'd like to follow along at home, we have STEM kits available at the teen desk you can pick up while supplies last. Without further ado, let's get started and see how science reveals the fingerprints we leave on everyday objects. First and foremost, let's define what forensics is. Forensics is the use of scientific tests or techniques to detect links to crime, thereby producing admissible evidence that complies with criminal law procedure. If you've watched any crime shows, you might have an idea of how important fingerprint evidence is in pinpointing a suspect and solving a mystery. The reason why is because each human being has a unique set of fingerprints that makes them a reliable tool for identification. With a magnifying glass, look at the pad of your thumb under a good light source. You will notice that you have some very fine lines and ridges that make up your fingerprint. These are called friction ridges, and they are what gives your fingers traction and the ability to grip and pick up objects. They are also what you see left behind on surfaces. Now here's what you should know about fingerprints. They are unique to you. They remain unchanged throughout your life. Even if you injure your finger, the skin will grow back in the same pattern. And fingerprints have patterns which provide a basis for classification. The main types of fingerprint patterns are loops, whorls, and arches. The loop is most common. It's a pattern that doubles back on itself, a loop. There's also the whorl, which resembles a circle or a whirlpool, and it's less common among the population. Then we have the arch, which is the rarest of all and has a wave-like pattern. In your STEM kit, you will find an activity sheet which tells you more about the unique characteristics of your fingerprint that sets it apart from others. Now that you know a little bit about your fingerprint, let's talk about why they're visible on certain surfaces. I mentioned that your fingers have friction ridges. These contain pores that serve as outlets for your sweat glands, and they leave residue on everything you touch. That's right, your fingers are always coated with sweat and oil and moisture. This organic residue we deposit when we touch surfaces is mostly salt and amino acids. As I said, fingerprints make a reliable tool for identification. The FBI created a digital database for storing fingerprints called AFIS, which stands for Automatic Fingerprint Identification System. Prints found on a crime scene can be scanned and lifted through this database to find possible suspects. The surface these prints are left on determines which kind of lifting technique will be used. There are two main kinds of surfaces, porous and non-porous. A porous surface would be paper, cardboard, or wood. Prints left behind on a cardboard box, for example, would stay put because the amino acids that we leave behind do not migrate once they're absorbed into the surface. A crime scene investigator would likely use a chemical solution called ninhydrin to lift a print from the surface. Ninhydrin, when sprayed on a print, reacts with the amino acids present and turns them purple, revealing the fingerprint, which can be photographed and run through AFIS. The other kind of surface is non-porous, which is what we'll be lifting from today. A non-porous surface, like glass, metal, or plastic, does not allow residue to be left behind and makes it more susceptible to be weathered away. When dusted over an invisible print, powder adheres to the moisture present and reveals the friction ridges. Afterwards, it can be lifted with tape and transferred. In your STEM kit, you will find a circular glass tile, a tin of cornstarch, and a brush. You will also need some clear tape. To begin this activity, let's start with dusting for our own prints. Take the glass tile and press your fingerprint on it for several seconds. You might not be able to see it very well, but that's the point of this. Next, you can open the tin and you can either dust over the powder with the brush, or you could simply just dip it and tap off the excess. And you can just barely see that I collected powder adhered to some of my lines. So it looks like I have a loop pattern. But if you do this with a brush, make sure you graze it in the direction that the ridges flow, and a very light print should form. You can try again if you're not satisfied with the result, but if you want a really prominent print, you can put lotion on your hands and that will help you get a better print. Once you're done, take a strip of clear tape, I made it into a circle, and then press it neatly over the tile. Make sure there's no air bubbles. And then I have just lifted a fingerprint. And then you can take the black paper. Then you can take the black paper in your craft kit. And voila. That's one way to do it. All right, for the next part of our experiment, we're going to be using a different technique for lifting our fingerprints from a non-porous surface. This technique is called fuming. We are going to create a chamber in which a chemical reaction will turn the latent prints into visible prints. Let's get started. From your STEM kit, you will need the following items for this next part. You need a jar with a lid, aluminum foil, a strip of cardboard, glass tile, and super glue. You will also need a large glass bowl. What we're about to do here is called cyanoacrylate fuming. Cyanoacrylate is a liquid adhesive, better known as superglue. It was discovered that when you heat cyanoacrylate, it gives off these fumes. And if you trap it in an enclosed environment with a piece of evidence, they will adhere to the amino acids present in your fingerprint and turn them white. I'll explain more about the chemistry behind this process in a bit, so let's go ahead and assemble our cyanoacrylate chamber. Our jar will serve as our chamber today. Inside, we will be placing our evaporation disc at the bottom, and that's just our aluminum foil. So what you're going to want to do is you're going to want to take your foil and fold the sides inward. So we make a little dish, a little square dish. Next, I'm going to press my fingerprint into this glass tile. This is the object that we're going to fume. All right. Then I'm going to take this bit of tape, glue it to the bottom, and put it on the cardboard strip. Next, I'm going to squeeze out the super glue into the evaporation disc. Now I'm going to put the evaporation disc inside the jar very carefully. Please and thank you. Okay. And then I'm going to put the dish inside. Might have to force it. Now for the next part, we're going to need to introduce heat so our cyanoacrylate can fume. So place your jar in the large bowl, and next we're going to pour boiling water around it. For the next part, we need to introduce heat so our cyanoacrylate can fume. Place your jar in the large bowl, and then pour boiling water around it. This process of fuming should take about 15 or 20 minutes. After a few minutes, you should notice that the super glue will start to fume. You might need to hold it in place. What's going on here is something called polymerization. Right now, these fumes given off by the cyanoacrylate are trapped inside this jar, and they're super sensitive to the residue that's left behind by the fingerprint. Monomers are molecules that can bond with other molecules to form polymers. So these fumes are giving off the monomers in the cyanoacrylate, and they're bonding with something in the amino acids called initiators. Initiators are substances that start chain reactions. While we're in this vapor phase, all these monomers are bonding and forming something called a dimer on our fingerprint. This continual chemical reaction is going to reveal our fingerprints in white because we have created a suitable environment for polymerization to take place. Ooh, it's working. You can see if you look at your tile, it's going to look a little frosty. And you can see the fingerprint in there. All right, I think I've given our object enough time to fume and bind with our amino acids. So, open it up. Don't breathe in any fumes if there are any. I'm going to take it out. see that? Yeah, and there's my fingerprint. And then you can lift it again with some tape. I'm going to put it on the other, next to the other one to compare. And voila. So you can compare your two tiles and decide which one you think came out better. I think definitely this one. If you look at it closely, you can also dust the one you fumed if you feel like it. In forensics, fingerprints can reveal more than just wavy lines. The residue we leave behind contains more than just salt and amino acids, but minuscule amounts of cellular debris called DNA. Now, DNA, which can be profiled through analysis, can provide even more identification towards a suspect. Forensics is a vast field to explore. If you're interested, we have several books on the topic, which you can find in our nonfiction collection under the call number 363.25, and we also have electronic resources. That's all for today, but I hope your experiment went well and that you learned something new. Until next time, take care.